All right, now we're on number 50. Last one. So the question is that the teacher gives us a slide with a double slit thing and a laser with a given wavelength, 632. And the laboratory asks that we determine the spacing between the slits. So the number A is just to list what kind of equipment we would need, and the only thing that we need is a meter stick to measure larger distances, a tape measure to get the small distance between the slits that we can't measure with normal stuff, and a large screen to catch the laser stuff. Okay, so B asks us to draw a detailed diagram of the experiment. So we have our laser there, our two slits, it shoots in the middle of them, and then part of the beam goes here, and then part of it comes back up there. So the things that we need to measure are the length between the slits and the screen that we have in place, and we need to also measure, so obviously it would give us like the interference pattern of the light and then dark areas. So we need to measure the distance between the first big light area and the second one. That's delta x. And then just to know that the distance between the two slits I'm calling x of m. And then C asks to sketch a graph of intensity versus position. That would be produced by this. And here. What I had is that the screen would have the first light area would be very big, and then each preceding one would be much smaller in each direction as it goes out. Part D is to outline the procedure that we would use to make the needed measurements, including how we would use each piece of the additional equipment that we sketched in A. So, okay, here we go. Shine the laser on the slits and use the tape measure to measure delta x being that, the distance between the two light areas. And then we would use the meter stick to find L. L is the distance between the slits and the screen, and then the screen is the screen that we use. So yes. And then E is to show explicitly how we would use the measurements using equations to calculate the slit spacing. So there's this equation that the distance between the slits equals magnitude times wavelength times length over the distance, delta x. So the magnitude is 1 because it's just the distance between the first light thing and the second one. So that's magnitude, that's m is 1. And we should know wavelength, they give it to us in the problem. We know L because we measured it with the meter stick, and we know delta x we measured with the tape measure. So we should know, so all variables besides x sub m are known, so we can solve for that, and that'll give us it. So yeah, that's everything.